Okay. Uh, Hello everyone. Good evening. So welcome to the first class of Fuzzy Sets, Logic and System and Applications. My name is Pravalika. I'm a PhD student and a Prime Minister Research Fellow from the Indian Institute of Science. I hope I'm audible. Can anyone confirm if I'm audible? Just please drop a message on the chat box. Yeah, cool. Thank you, Anurag. So yeah, so I'm supposed to give a small introduction about myself and what research I do. So to give a gist, I work on AI and ultrasound imaging modality. And I'm interested in other modalities as well, but my primary research focuses on fetal ultrasound. So yeah, that's my whole area of research, and I'm currently in my second year of PhD. And as said, I'm from Indian Institute of Science. So I'll be your TA for this whole course, and we'll be having 12 weeks of classes. And at the end of on the 13th week, I'll be taking one more extra class where I'll discuss the summary of the entire course, and I'll also make sure in case if anyone wants a topic which is relevant to this to be covered, I'll be doing that in the 13th week as well. Okay, so I hope I'm clear with all of that. So a couple of I want to just give a couple of instructions before I begin. So the first and foremost is this session is being recorded. Okay, so whatever you say here, everything will be recorded and it will be put online on YouTube. Okay, and you will be getting the YouTube like from the YouTube. You will be getting the YouTube link in the NPTEL portal itself. Okay, so everything will be updated there. Then you can directly access it. So once this class is done, most probably by tomorrow morning or afternoon, I'll be uploading it on YouTube and sharing the link on the portal. And the whole notes, presentations, and whatever I write. So I prefer writing rather than PPTs. So whatever I write, that notes will also be shared with you in a Drive link. Okay, you can access everything from there. And since this course uses MATLAB, I'll be also sharing some MATLAB files later on in the course, as and when required. Okay, so those also will be accessible in the Drive folder, and that Drive folder link will be available on NPTEL portal itself. So I hope that's clear. Okay, and yeah, whatever questions you have, kindly put it only on the chat box, and I'll read them and I'll let you give you the answer immediately. Okay, I don't like being interrupted during the session, so I kind of uh, do not respond. Okay, so once I cover some topic, I'll again look back at the chat box. I hope I'm clear. And in case if you have any issues in between, audio issues, video issues, or anything like that, if there's a lag, just drop a message in the chat box. Okay. Um, yeah. So in these sessions, please don't expect me to cover most of the theory part. You have to do your theory part from the videos, lectures that are already given to you on the NPTEL itself, right? So please go through those videos first, because in this class, I'll be focusing more only on the assignment questions and on MATLAB coding going forward. I hope that's clear. So please kindly make sure that you watch those videos first and then come back here. Okay. And mostly whatever assignment questions which were there from the previous years, all those things I'll be discussing. Okay. So with that, let's just get started. So the first and foremost question of this course is, what is a fuzzy set? So since this is a first class and there's not much assignment questions to discuss on, so I decided to have kind of some theory. Okay, not too much theory. I will be giving only just a top level things. Okay, I don't go deep into all of the theory part, so I'll just give you whatever knowledge I have. I'll just show it now. Okay. um, yeah, so let's start with this fundamental question. What are fuzzy sets and why exactly do we need them? So to answer this, let's think about how we usually describe the world around us. for instance, if someone asks you if a glass is full, right? You might say yes or no, but this is just a Boolean foundation, right? So which operates in binary, either true or false, and 0 and 1, how our normal systems work, right? But let me ask you this: what if the glass is half full or almost full? A simple yes or no fails to capture in between reality, right? So this is where fuzzy logic comes into play. So as said during the class, it is proposed by Lotfi H. Other in 1965, and fuzzy logic allows us to deal with uncertainties, partial truths, and vague information. So it assigns a degree of truth to a statement ranging from 0 to 1, which we call it as a membership function. So this membership function, this kept on coming in your assignments, right? So that is basically a degree of truth. Okay, how much of that is true, right? Okay, for example, in a fuzzy logic, the class being half full might have a membership value of 0.5. So it's 50% full or 50% empty, which means it's the membership value is 0.5. If I'm saying the membership value is 1, it either means the glass is completely full or completely empty. One of those, based on what we are saying. Okay. So that is what fuzzy sets are. And they are basically the mathematical representation of this whole logic, the glass being half full, half empty, that kind of logic where we put everything into a mathematical representation. That's fuzzy sets for you. So unlike the traditional sets where an element either belongs to the set or it does not, fuzzy sets allow partial membership. So which means, for example, if we are taking only integer set, if I say I want 0. To add 0.5 into the set, which is not true, right? 0.2 does not exist in a classical set of having only integers, because 0.5 is a real value, right? I can't bring it up into a set of integers. So in this way, but in fuzzy set, it's not that way. So in fuzzy sets, we allow some partial membership. That is the degree of truth. So another example from the class, right? For example, if we are talking about tall people, let us say someone is 5'8", 5'8" might belong to the tall category with a membership function, let us say 0.7, while someone, let's say, is 6'3" might belong to the same category with a membership of 1. So in essence, fuzzy sets and fuzzy logic helps us model the complexities of the real world, where boundaries are not always clear and truth isn't always absolute. Okay, I hope you all got a gist of what fuzzy sets are. And now let's just connect this fuzzy logic to a broader and exciting domain, which is artificial intelligence. So we keep on hearing this term artificial intelligence in everything that we do and everything that we hear, right? So AI is all about mimicking human intelligence and behavior using algorithms and computational models. So let's face it, human reasoning isn't always black and white, right? We deal with a lot of uncertainties and approximations in our daily life. For example, when driving, you don't make binary decisions like press the brake completely or don't press it at all, right? So you basically ease onto it depending on the situation, like the car's speed, the distance to the vehicle ahead, and other factors, right? Similarly, even fuzzy sets provide a way for machines to handle such nuances. So wherever such a new scenario comes, fuzzy set helps these machines to think, like, to handle the situation in a different way. Okay, so fuzzy logic is a really key agent I can call for artificial intelligence. So alongside neural networks and evaluation algorithms, fuzzy sets is an agent for AI. So while neural networks deal with learning patterns and evolutionary algorithms handle optimization, fuzzy sets are important at reasoning under uncertainties. So for every situation in any way, there is always an uncertainty that we or the model face. So fuzzy set will basically give you a reason on how to make a decision. Okay, you in the sense, not you, for AI. Okay, so a classic example of fuzzy logic in AI is in control systems. For example, air conditioners or washing machines, right? So, what do we do with washing machines? We basically select what kind of mode that we want. So, if we are washing beddings, then we use the mode bedding. If we are washing gentle clothes, we use a more gentle, right? And sometimes we also change the water level according to our own thing, right? If I want to use more water, I'll do it. If there is a water scarcity, I'll put the water level to be very low, right? So these all these systems, for example, air conditioners and these washing machines, they take such inputs, right? Such as high temperature, low temperature, water level, low water level, and anything else. Yeah, we can just say this for now, right? And they basically take these inputs and use fuzzy rules to determine the action that a machine have to take. Okay, so similarly, even in AI applications, fuzzy sets enable systems to process natural language, understand instructions, and make better decisions. So, in fact, fuzzy logic works beautifully when combined with other AI techniques, leading to hybrid models. Okay, like neurofuzzy systems. Okay, so if you want to know more about neurofuzzy and use them on MATLAB, there is also a toolbox for that. Right. So that's out of the scope of this course, but I just wanted to let you know. And yeah, these models can basically learn from data while also reasoning with fuzzy rules, making them extremely powerful in other fields like robotics and medical diagnosis, financial forecasting, and other things. Okay. So I just have taken this artificial intelligence, machine learning, and deep learning from a blog, which I felt like giving a really good gist of what is what. Right. So I just added that here. Again, a small history which was discussed in class by Sir again. So we all know that John McCarthy found the founding father of artificial intelligence. So a perceptron model is nothing but where is this perceptron? Okay, in 1957, the perceptron model was introduced. So it is nothing but it's again an artificial neural model. So the difference here is just the activation function. So perceptron model is an ANN model with activation functions as binary linear. So okay, so this history of AI kept on going, and notably in 1965. So fuzzy logic was proposed by Professor Lotfi A. Zada, and this is a time when deep learning term, which is very relevant and very popular term that is being used nowadays. It was coined in 1965 by Evancho and Lapa. And after that, evolutionary computing came, and then neural computing, and in 1990s, the hybrid model, which is the neurofuzzy system, has also come. So where neural networks and this fuzzy logic, everything are combined together into a hybrid model. Okay, so yeah. Again, to give you a gist of what fuzzy sets are, what membership functions are, and what are soft and hard terms are. So fuzzy system is also one of the key agent of computational intelligence. Okay, and computational intelligence basically is a set of naturally inspired computational methodologies and approaches to address complex real-world problems to which conventional mathematical or traditional modeling can be useless. So now coming to the fuzzy set system theory, which is based on fuzzy logic. So when Professor Lotfi has proposed this, he proposed the idea of fuzzy logic in 1965, and the theory differs from conventional computing because the conventional computing is based on bivalent logic, that is the Boolean logic that we call as. right? Whereas this is a multi-valued logic. So in this fuzzy set, it involves soft or partial truths, or okay, or partial faults. So soft because the truth, if it is soft, means it is that it is true, but not 100% true. Okay, it might be 20% true or 30% or maybe 90% as well, but it's definitely not 100% true. Okay, so if we are saying it's soft, it is somewhere in between 0 to 100%, or false in between 0 to 10%. So if it is 100% true, the truth is hard, or the false is 100%, it means the false is hard. So when we are saying 100%, we say it as hard. If it is somewhere in between 0 and 100, we call it as soft. Okay, I hope you get what those soft and hard terms are. And we just can't just say that it is a soft truth or a hard truth. Instead, we also have to assign a degree of truth for it, right? So how much of it is true or how much is it false? So we use the membership functions, so which is basically a value in between 0 to 1, right? So that basically indicates its level of belongingness. Okay, so this is how we reason. Sorry, in Boolean, the difference between a Boolean logic and a fuzzy logic. So the truth values, where Boolean has just true or false. In fuzzy logic, we have degree of truth, right? How much of it is true, right? The values in between. And for reasoning in a Boolean logic, we use the binary operators, right? So like and or not. But in fuzzy logic, we use something called as graduals, that is T norms, T conorms, and all of that. Okay, so and again, this is a brief history of fuzzy logic, which was already said during the class, right? Um, so interactive problems. So how do you explore fuzzy logic concepts? So first, let us say there is a situation where you want to use fuzzy logic. So how do you approach that problem? Right. The first one is a scenario classification. So you have to classify a scenario whether it is a fuzzy or a Boolean logic. Right. For example, let us say you have a biomedical image, and your model have to detect if there is cancer or no cancer, just yes or no. Okay, it's just a binary classification. So for that, you don't need something as fuzzy, right? You need only a Boolean. You are only going to output one of the two possible outputs, right? Has cancer, does not have cancer, right? So that time you use a Boolean logic. Whereas if there is a lot of things that are involved in a situation, for example, like a washing machine, right? You keep changing a lot of things with the user interactive panel and everything. You change a lot of things and you get outputs, and you get different outputs for it, right? So you basically first you have to classify the scenario whether it is fuzzy or whether it's Boolean, and then you apply, if it is fuzzy, then you apply the concepts of membership and truth values. Okay, and then you for the membership function calculation, you just perform a simple calculation on membership function, determining the degree of membership for elements in fuzzy sets. We'll see how we are going to do this as well. Okay, um, and then you come to the conceptual question, which means answer conceptual questions like what are the key differences between randomness and fuzziness, or something like that. Okay, that is just an example here. So these are various membership functions that were discussed during the class, right? So not all of them were discussed. A couple of them were discussed this week, and the rest of the membership functions will be covered in the next week. Okay, so let's just go through a couple of things here. So I hope most of you have installed MATLAB or have access to MATLAB. In case if not in this class, I recommend you to have access to MATLAB at least in the later classes. Okay, So just give me 1 second. I'll just open these links. Okay, so the first link here is basically a fuzzy logic toolbox. Okay, so in case you have installed MATLAB, so just add this toolbox as an add-on to it. Okay, so this have all the necessary membership functions and other functions that we need in it, and we will be using it. Okay, so basically we use this toolbox to design and simulate some fuzzy logic systems. Okay, so that's the first one. Okay, I'll just discuss these membership functions. Okay, like to tell you like how to go through these and how to understand these. If you can just give me a minute, I'll just log into my MATLAB thing. Uh, so it's I'll just open this. Meanwhile, you guys can have a 5 minute break. Okay, we'll again start back at 6:26. Okay, so everything is ready. Can I just start? So yeah, so this is a whole documentation of Fuzzy Logic Toolbox, which we will be using throughout. Okay, so here, if you wish, you can go through the entire documentations for everything where uh, how you can use fuzzy logic for explainable AI, okay, and for fuzzy logic deployment and inference system tuning, and in also Simulink. Also in Simulink, also you can use fuzzy logic. So in case you are completely new to MATLAB, I suggest you to take up the MATLAB on RAM course and also the Simulink on RAM course. So those will be really, really useful for you in case if you are a complete beginner to MATLAB. Also, in case if you are facing any issues with MATLAB, like installations or anything, just let me know. Okay. And yeah, in case if you are using MATLAB online, then you have to add this fuzzy logic toolbox as an add-on, which I'll be showing you in a couple of minutes. Okay, so this is the fuzzy logic toolbox. So whichever documentation you want to go through, you definitely can go through. But for now, I'm going to stick with the membership functions which were discussed during this week's class. Right. So I have opened the documentation of the triangular membership function. Okay, so the function for the triangular membership function is TRIMF. Okay, so TRI for triangular and M for membership and F for function. So in every like for every membership function, there is a different syntax. Okay, so the different keyword and there's a different syntax. So for the syntax of triangular membership function, y is equal to TRIMF, comma, x, comma, parameters. So what are these parameters? So sir has explained this during the class, right? Uh, so if x is lesser than a value a, then it will return the value 0. And again, if x is greater than c, so basically in this you give three parameters a, b, and c, like the three points of the triangle, okay, a, b, and c. And in case if a value x is less than a, then it is by default 0, and if a value is greater than c, it is again by default 0. But if it lies in between 0, a and b and c, it will have a different values, such as this right here. Okay, we'll see how this is calculated and everything. Okay, so in order to make this whole part more compatible, it is given in this way, right? So first you calculate these two values, x minus a by b minus a, comma, c minus x by c minus b, and then you pick whichever one is the minimum of those both, right? So then you have one value from this, and then you have 0. So whichever one is maximum, then the membership function value is going to be that. Okay, so let's give it a try in MATLAB. But before we start MATLAB, so this is MATLAB online. Okay, so I'm using MATLAB online. Okay, in case if you only use MATLAB online, in case your system is really bad and it won't support the huge MATLAB application. Okay, so this whole thing is a command window, and on the left side you have the files, whichever files you are accessing, and at the bottom you have a workspace. So here, whichever mm, variables you are declaring, all those variables will be given here. The names will be given here along with the values. Okay, so in the command window, whatever you write, it is not going to be saved. Hence, you need to open a new script. Okay, so this part is exactly where you are going to write your entire code to save it as a file. Okay, I have created a folder called fuzzy, and this is where I want to save this. Okay, so CLC stands for clear everything and clear all. In case if there is anything in the command window, so whatever I'm running here, the command window will automatically like display most of the stuff here. So if I don't want to keep seeing the same thing, I'll use the function clear all in case if there are multiple windows open. For example, if there are plots, okay, multiple plots which opens in separate windows, if I don't want them, then I will use close all. Okay, so just by default make a habit of having all of these in case if you don't want anything on your screen to be there over and over again, right? So MATLAB works just the way how you um, in generally use other programming languages, right? If I say a is equal to 5 and if I run, I will be getting the a value in the command window here. Okay, so and another thing is when you use a semicolon here, nothing will be displayed at the command window. But if you want that value to be displayed at later point somewhere, then you just give the variable name there, right? And that same variable is saved in the workspace all the time. Okay, so this is how MATLAB works. And let me take an example from the documentation of the triangular membership function. Okay, so what does this do is basically I am taking values from 0 to 10 with a variation of 0.1. Okay, so x has values from 0 to 10 with a difference of 0.1. Okay, so let us just see how this x works, right? Now the values of x started from 0 and increased by 0.1 and then again increased by 0.1. Like that, it just kept on happening until it reaches 10, right? So now we have x values to be from 0 to 10 with a difference of 0.1, right? So, okay. Now let's evaluate the membership function. Evaluate the membership function. Okay. So we are using a variable y to store the values that are that comes out as an output from this, right? The membership function, and then x, and then we have three values, 3, 6, and 8. So these three represent the triangle. So 3, 6, and then 8. You'll see how this works. Okay, and let's print out y as well. Print down somewhere. We'll just cover this off so it will be easier for us to identify what is what. So when x value is 0, the y value turns out to be 0. When the x value is 0.1, then again the value of y is 0.1. So this is some sort of a trend kept happening till one point, and then again the membership function has reached. So in order to understand how this is, let us plot the output. Okay, we'll just take from here. So here what we are doing is we are plotting x and y, right? And we have the values 3, 6, and 8. A, B, C values are 3, 6, and 8. And our x-axis is basically x, and y-axis is the degree of membership, right? So that's the membership function, membership value, or the degree of truth. Okay, and it's just limits. So now we got the figure. So at x equal to 3, we have 1 point, and at x equal to 6, we have 1 point, and at x equal to 8, we have 1 point. So this is basically A, B, and C, right? So this x-axis are the values of x, so ranging from 0 to 10, and following the same thing here, that is this or this. Okay, this function, we are calculating the function, we are calculating the y value, and then we have plotted it here, right? So for all the values below 8, that is below 3, are 0, right? So that is what our triangular membership function as well. So for all the x values less than or equal to a, it is 0. So we have all the membership values less than 3 and equal to less than or equal to 3 are 0. And again, greater than or equal to c, that is 8, is equal to 0. And in between, the values are x minus a by b minus a, and c minus x by c minus b, right? So this is how a triangular membership function is calculated and plotted. Okay, I hope this part is clear. And similarly, you can also try a trapezoidal membership function. So where in place of 3 parameters, now you will have 4 parameters. Okay, in case you are giving 2 parameters of equal values, then again it will fall back to triangular membership function. So why does this happen? We will see. Okay, even for trapezoidal membership function, there is, sorry. So this is a value that is computed. So you take the minimum of x minus a by b minus a and b minus x by b minus c and 1 as well, right? So you take the minimum value of all of these, and then you take the maximum of in between this value and 0, whichever is maximum, you take that value. So this is a membership function, right? So let us try for the same thing. So now we are trying trapezoidal membership function. So do drop any message in the group in case if you, sorry, in the chat in case if you have any questions. All right. Okay, nothing so far. Good. Okay. So let's just call this as y1. Okay. So now I'm giving 4 different values: 1, 5, 7, and 8. So 1, 5, 7, and 8. Okay, 4 different points of a trapezoid, right? So let's run this. Sorry, I forgot. Okay. Now we have this. So let us give a plot here with the same values, but y1. Okay. Okay, now we have got the trapezoidal membership function. So the values are 1 and 5. Okay, we have 1, we have 5, we have 7, and we have 8, right? So all the values below 1 are 0, all the values above 8 are 0, and in between, whichever values are there, those are calculated using this function here, right? So all of these functions were discussed during the class, and similarly we are using the code here. Okay, I hope so far it is clear. Okay, you can play around with this whole thing. The code will be shared with you. I'll be putting all of this in a drive link, and that drive link will be shared uh, on NPTEL portal itself. Okay, so this part is done. The other things. Okay, similarly, if you want to try out other membership functions as well, you can find the documentation and you can know which membership function you want to use, and then you can directly use it. Okay, in case you don't want to save it in a file, and if you want to like do some sort of calculations, you can directly do it in the command window itself. Okay, for example, 5 plus 3, you will get the value 8, right? So such things won't be stored in the code, but in case here and there, if you just want to try, you can just use the command window. Okay, this is I'm just telling this for the beginners, absolute beginners. Okay, in case any one of you faces any issues with MATLAB, okay, do let me know during the class hours from 6 to 8 every Friday, and you can also drop a message in the Google group, which is there in the NPTEL portal. Okay, so either me or the course TA, one of us will definitely reply. Okay, I hope so far we are clear. Just stop here. Yeah. So now let's try to do some assignment questions, and let's just have some hands-on kind of thing. Okay. Just give me 1 second. Okay, so I'm more of a writing person rather than a presentation person. So I'm just preferring. So from next class onwards, I'll not be having any PPTs and all of that. I'll be just writing while I teach. Okay, but for now, I have prepared everything beforehand so as to not waste a lot of time. Okay, so to give you a understanding of the difference between what a general or a classic set is and what a fuzzy set is, I have prepared some notes where a set is basically a collection of objects. Okay, so if you are taking the universe as X, so capital X equals to universe, and there is a small set in the entire universe that is denoted by small x. So this small x completely belongs to capital X. Okay, and then set A is equal to X such that X meets certain conditions and X belongs to the universe. Okay, this is mandatory. The X should contain in the universe. For example, so this is an example taken from the class. X belongs to uh, 15 to 20 values. Okay, and X belongs to your universe, and this universe is set of all positive numbers. Okay, all the positive integers. So I can rewrite these two lines like this. So A is equal to set X such that X lies in between 15 to 20 but not equal to 15 and 20. Okay, and X belongs to E. And in more general terms, if I'm just giving values, then it is nothing but 16, 17, 18, and 19, right? So this whole thing is a classical set. And I can 100% say that the values 16, 17, 18, and 19 100% belongs to this set, right? So they all belong to the positive set of integers, right? So they belong to the universe. They all lie in between 15 to 20, right? So I can 100% say that these four values belong to that set, right? Hence, I can say that the membership value of all these elements, that is each element 16, 17, 18, 19, is 100%. Or if we are telling that in terms of just numbers, then 1. The membership value of all of these values 16, 17, 18, 19 is 1. Okay, as they are 100% present. So this membership value is basically showing you the percent of belongingness of the particular number, or a particular number in that set. Okay. Whereas in fuzzy sets, these membership values lies in between 0 and 1. In a classical set, the membership value is always 1. In a fuzzy set, the membership values always lie in between 0 and 1. Okay. If it is 0, then it's not part of fuzzy set. Okay. If there are multiple numbers in a fuzzy set and not even one number in that fuzzy set has a membership value of 1, then you can call it as a subnormal fuzzy set. Okay, this is kind of important to note too. You can kind of remember this one. Okay, so in case not even at least one number should have a membership value of 1 in a fuzzy set to call it a normal fuzzy set. If none of the numbers in the fuzzy set has a membership value of 1, then you call it as a subnormal fuzzy set. Okay, so for example, we are again taking the same value numbers. Okay, 16, 17, 18, 19, and all of them has different membership values now. This 0.6 is a membership value, 0.9 is a membership value of 17, 0.2 is a membership value of 18, and 1 is a membership value of 19. So from the first part, I can say that the number 16 is 60% present. Okay, and the number 17 is 90% present, whereas the number 18 is 20% present, whereas the number 19 is 100% present. Now I can call this whole set, this whole A, as a fuzzy set. In case if there is no one membership function 1 here, membership function value 1 here, then I call it as a subnormal fuzzy set. But this whole thing is a fuzzy set. Okay. So let's look at how we represent the fuzzy set. Okay. So let's just call A as a fuzzy set, represent A as a fuzzy set. Okay. And new A is the membership function of the first element. New B is the membership value of the second element. Similarly, so many others. Okay. And then we have x1, x2. So this is new A of x1, new B of x2, and divided by x1, x2, and this one is x2. Okay. Please note that this by is not division, and this plus is not addition. You are simply representing in that form. Okay. You are not adding anything up. You are not dividing anything up. Okay. So please kind of note that. Okay, and now let's write this whole part like a summation. Okay, summation new of xi divided by xi. Okay, for all values of x, capital X. That can also be written in this way. So first you just give the element value, the comma, you give the membership value of that element. Okay, like this. So basically element comma membership function of element. Okay, this is how you represent one part. So similarly you will have multiple elements of in that whole set, right? So each set you write like this. Yeah, sorry, each pair you write this way. Okay, so the element comma, then you give the membership value of that element. For all elements you give that, and for all elements that belongs to the entire set. Okay, this is how you do for finite and discrete values. Okay, in case if the values are infinite and continuous, then you represent them using integral. Okay, so how we are using summation here. For continuous value you use an integral here. Okay, so all good. So let's take this one from here. And let's just try to write it in this form. Okay, let's give the representation of this in a better form, right? So a is equal to, so for the first one, the membership value comes in the numerator, and in the denominator you get the element, right? So here you have the membership value at the top, and then you give the element, right? So 0.6 by 16 plus 0.9 by 17 plus 0.2 by 18 plus 1.0 by 19. Okay, so this is one sort of representation. So this is a third type of representation. This is the first type of representation from here. All right, so since this is finite value, we have represented it this way. Okay, so now let's look at some previous assignment questions. So these questions are kind of similar to the assignment questions that you are currently doing. Okay, so please don't think that that and this are both same, whereas both are completely different actually. Like the values at least are different. Okay, so these are taken from the previous years. Okay, so try to solve them by yourself. First, I'll give the question and I'll also give you the options, and I'll wait for some time for you to figure out and try the questions. And then I will again discuss the whole solution. Okay, I'll wait at least 3 minutes for every question. Okay, so what is the membership function for a triangular membership function? Okay, this is just a triangle. Okay, with parameters a equal to 1, b equal to 5, c equal to 9, when x is equal to 7. Okay, and your options 1.0, 0, 0.5, 0.0, none of the above. So please find the membership function for a triangular membership function with the parameters a equal to 1, b equal to 5, c equal to 9, when x is equal to 7. So now you have a value, b value, c value, and x value. You also know the triangular membership function as well, right? I'll give you 3 minutes. Let me just put a timer up. And once you're done, just drop a message in the chat box. Okay, just drop your answer in the chat box. We'll see how many of you got it right. Okay, so it's absolutely fine if you made a mistake. It's okay. It's okay to make mistakes. Okay, I will be discussing the solution at the end of 3 minutes. Okay, your time has already started, so please do it and just drop a message in the chat box once you're done. Okay, so time's up. So Yamuna, Sayan, Abhishek, Abhirami, you all are absolutely right. So the value, so the answer is 0.5. Okay, let's do the solution once. So let's write the triangle membership function, right? X a comma b comma c, that is equal to max of minimum of x minus a by b minus a comma c minus x by c minus b, and then 0, right? So let us calculate x minus a by b minus a first, right? What is x? 7 minus 1 by 5 minus 1, 6 by 4, 3 by 2, right? And then we have c minus x by c minus b. So 9 minus 7 by 9 minus 5, that is 2 by 4 is equal to 1 by 2, right? So first we are picking the minimum of these two, right? So the minimum is, this is 1.5, this is 0.5, right? So when we are picking the minimum, it is going to be 0.5. So max of 0.5 comma 0. So the maximum in between 0.5 and 0 is 0.5, right? Hence the answer is 0.5. Good. So let's try another question. Again, triangular membership function, and the parameters are a is equal to 1, b equal to 5, c equals 9. And now find maximum of x. Okay, sorry, not maximum of x. Find x such that the membership function value is high. Okay, so I'll read the question once again. For a triangular function, membership function with parameters a equal to 1, b equal to 5, c equal to 9, find the value of x for which the membership value is maximized. Okay, so the options 5, 1, 9, and none of the above. Okay, there are two ways you can do this. Okay, one is that you can take these values and you can put it in the membership function and see which one is giving you the highest membership value. Okay, that is one way of solving it when you are having a multiple choice. Another way is to take the function like y equal to something, differentiate it once, okay, then equate it to 0 and then try to get the values. Okay, that is another way of doing it. So the second one is a long one, and this one is a since you are already having your choices, you can actually prefer putting these values in place of x, like putting x equal to 5 and x equal to 1 and x equal to 9 in the membership function and try, and then you can try it. Okay. Okay, there is some question. What is it? See, this is not the platform for you to ask about NPTEL refunds and things like that. If you're having any questions regarding this course, okay, the content of this course, please drop a message in the chat box. And anything that you have with the entire NPTEL thing, please send an email to NPTEL people, to the support team. They'll be glad to reply to you. Okay, this is not the place for asking about all of these things. I have no idea. Okay, regarding the course, you can ask me anything and I'll answer. We'll wait one more minute. Okay. Yeah, we'll go ahead. Um, Abhirami, Sindhu, Renu, and Yamuna, all of you are right. So the answer is 5. So let's just take the same one from here. And let's put the values. Okay. So let's take x minus a by b minus a. You can, let's first try it with x equal to 5. Okay. 5 minus 1 divided by, what is the value be? 5. 5 minus 1, which is equal to 1. Okay, then c minus x by c minus p, that is equal to 9 minus 5 divided by 9 minus 5 is again equal to 1. Oh, okay, right? So the maximum of 1 comma 0, that is always equal to 1. So the highest value of X has already been achieved. Right, sorry, the highest membership function has already been achieved. The membership function value always lies in between 0 and 1, right? And hence, since all 5 already gave you the highest value, highest membership function value possible, then you don't even have to go to the other things, right? So for now, 5 x equal to 5 is the right answer. Great, guys. So let's look at another question. Okay, so again, triangular membership function. A equals 1, B equals 5, C equals 9. And now we are saying B is changing from 5 to 7. Okay. Then which of these statements that I'm going to tell next are true? Okay. At x equal to 3 and x equal to 7, the membership function value will be 0.5. At x equal to 4 and x equal to 8, again all of this ditto and 0.5. And at x equal to 5 and x equal to 7, all of this 0.5. D, none of the above. Okay, I'll give you 3 more minutes again. At 7:10 we'll try. So just like a small hint, you have to consider this A value, this B value, and this C value, and then take first x equal to 3, try to get the membership function. In case if it is equal to 0.5, then try x equal to 7. If one of those two are not equal to 0.5, then leave that. Then go to x equal to 4, try, find the membership value. If it is equal to 0.5, then try the next part. In case if one of them is not, then just go to the next part. Like that, you have to try for x equal to 3, x equal to 7, 4, 8, 5, and 7. Again, 7 again you have already done. Right? 3, 4, 5, 7, and 8. So 5 times you have to do for the same equation. You have to keeping the values in. Um, okay, for this question, why don't we just give what are the membership values you have got for x equal to 3, x equal to 4, x equal to 5, 7, and 8. I just want all the 5 values. Can you guys do it? Let's write it like a table. And x and the value. Okay, for 3, 4, 5, 7, and 8. Please give me the membership values for all values of x here. Okay, any answers? What is the membership function you have got? Sayan, can you once recheck the formula that you have used and the calculations? Anyone else? If you want a minute or so, just drop that message as well. I'll just wait. It's fine. We have time till 8. Option D, none. Okay. Uh, can each one of you give me what values you have got with respect to each x? Like for x equal to 3, what is the membership function value you have got? For x equal to 4, what's the value? 5, 7, and 8. Is equal to 3, 4, 5. The function is equal to 0. Okay. What about 7 and 8? Renu? Okay, let's try doing it once. Okay, because there are different answers that I got when I did. So just give me a second. So at x equal to 3, what are the values? A equal to 1, b equal to 5, c equal to 9, right? These are the values. Yeah. So max of, minimum of, um, 3 minus 1 divided by 7, sorry, b will change from 5 to 7, right? So this this is going to be 7. 7 minus 1, comma 9 minus 3 by 9 minus 7, comma 0, right? Okay. Max of minimum of 2 by 6, comma 6 by 2, comma 0. So this is 1 by 3, that is equal to 0.33, and this is 3. If we are taking the minimum, then max of 0.33, comma 0, and the maximum of these two is 0.33. So for the value x, the membership value is 0.33, right? So in the question itself, we said B is changed from 5 to 7. So the value of B is 7 and not 5. That is probably one of the reasons why most of you got different answers. Okay? Yeah, I understood it now. Okay. So I think you guys can solve these. Okay, I'll put the values here. And this has 0.5 and 0.5 here, x equal to 5. Okay. So this is the final. You can try out with others as well. Try it out. Okay. So for this, the answer is B. Okay. So in case if you are going to write exam for your certification for this course, I'll be honest, please read the questions clearly. I have actually given the same course probably 3 years ago as part of one of my courseworks. I have taken up this course as a student. So I'll, as a suggestion, kind of read all the questions, like point to point. Don't be in a hurry. This is a really, really easy course, but don't just skip most of the things in the questions. Okay? So cool. Let's look at the next question. What is the membership value for a trapezoidal membership function with parameters a equal to 0, b equal to 2, c equal to 6, and d equal to 8 when x equal to 6? Your options 1.5, 0, and none. Okay. Again, let's take 3 minutes for this. Okay. As hint, I'll just give you the formula also. Okay. Yeah. Let's just take 2-3 minutes to finish this off. Okay. Abhirami, Abhishek, Sayan, and Yamuna, and Renu, all of you are right. So the answer is 1. So let's do the solutions for others. Okay. So let's just keep the values here. Let's calculate x minus a and b minus a first. 6 minus 0 by 6 minus 2. Oh, oh sorry. B minus a, right? 2 minus 0. So d and d minus x by d minus c. 8 minus 6 by 8 minus 6 to 1. Okay. So minimum of 3 comma 1 comma 1, that is equal to 1, and then we'll take the maximum of 1 comma 0, that is equal to 1, and all of you are right. Nice. Okay, let's move on to the next question. Fifth. So again, a trapezoidal membership function, and the parameters are a equal to 0, b equal to 2, c equal to 6, and d equal to 8. Find the values of x for which the membership value is maximized. Again, like previous. But now the values of x is less than or equal to 0. The value of x is greater than or equal to 8. Values of x lies in between 2 and 6. D, none of the above. So a small hint is that for the first option, you can just put the value of x equal to 0 and see what is the membership function that you're getting. Or you can put x equal to 8 and see what you're getting. And then give one of the value in between 2 to 6 or any other value and see and try. Okay, let's just take 3 minutes again for this. Just a second, I'll just take the values from here. Let's just give one more minute for others to do it as well. Okay, so let's just do it. Uh, Yamuna, Sayan, Abhishek, and Suresh, you all are right. Okay, so one way is to just take the values x equal to 0, x equal to 8, and some value in between 2 to 6, and put it in the function, right? That is one way of doing. Another way is simply drawing the graph. Okay, this is the trapezoidal membership function that we all know, right? It is starting from 0. So since a equal to 0, the a, b, c, and d, I have put all the 4 points, right? So for x less than or equal to 0, all the values are 0, right? So for the first one, all the membership values are 0, for because here everything is else is 0, right? From the membership function, trapezoidal membership function definition itself, right? For all x less than or equal to a, it is equal to 0, right? And hence it's all equal to 0. And for all x greater than or equal to 8, that is all the values here, again it is 0. And for the values in between b and c, that is 2 and 6, the membership value functions are equal to 1, right? So when it is less than b and greater than a, it is an increasing function. And when the values of x are greater than c and less than d, it is a decreasing function, right? But when it is in between b and c, that's the highest peak of membership function that we are going to achieve in a trapezoidal membership function, right? And hence we can say that this is where the maximum values lie. Hence option c is right. Okay, this is one way of doing. Another way of doing is simply putting the values 0, 8, and one value in between 2 and 6 in the membership function and getting it. Is this clear, or is there any doubt? I can explain this again in case if you are having any doubt. Okay, I take that there are no doubts in that. Okay, let's do another question. Okay, for a trapezoidal membership function with parameters a equal to 0, b equal to 2, c equal to 6, and d equal to 8, that is same as the above one. If I'm changing b equal to 2 to b equal to 4, then which of the following statements are true? So for x equal to 1 and x equal to 7, the membership function value is equal to 0.5. Sorry. Okay. For x equal to 2 to x equal to 7, again the membership value is equal to 0.5. And x equal to 4 to x equal to 7, the membership value is equal to 0.5. And then it's none of the above. Okay, let's do it like from previously how we have done. Let's do it the same way. X and the value. We have 1, 2, 4, and 7. Okay, we don't, last time we had more than these. So now it is at least reduced, right? So let's find out the membership value function values for each of these terms, and then tell me which of these statements are true. Okay, please note that the value of b has changed from 2 to 4. Okay. So okay. Okay, so there are two kind of answers that we are getting from people, option A and option B, right? So I'll just give the values here. So for x equal to 1, the value is equal to 0.5. For x equal to 2, the value is equal to 1. For x equal to 4, the value is equal to 1. And for 7, it is again 0.5, which in turn is making option B as the right answer. Okay. So Abhirami, once please check check where you have gone wrong. Oh, sorry. I think I made a mistake. Sorry. I was looking at a different thing. Sorry. Uh, 1 is 0.25, 2 is zero point 0.5, and 4 is 1, and 7 is 0.5. Okay. Uh, so what values Cyan has given, so those are right. Okay. Option B is the right answer. Okay. Um, Sorry, I actually cross-checked my notes with science answer, and I thought I'll just see there and just write it down here. But then by mistake, I have again copied other answer. Okay. Sorry, Sayan. Okay. Okay, cool. Uh, let's get to the next question. Theory. Oh, I don't have other questions. Okay, we'll just try a different one out. Okay, I'll give you a question to which even I haven't done. I'll also be doing with you guys now. Okay, so this is the last question for this class. Okay, so let's take a trapezoidal membership function, and parameters are a equal to 0, b equal to 3, c equal to 6, and d equal to 9. And at x equal to 7, what is the degree of membership? Okay, the values are 0.67, 1.33, and none of the above. Anurag, what haven't you understood? Can you please tell what you haven't understood? I'll just tell it to you. Previous question solution. Okay, let's just finish off this. I'll go back again to that question so that others won't get confused. Okay. I'll just get this one here. Okay. So 0.67 is what majority is saying. Okay, let us just try and figure it out. Okay. Let's just write x minus a and b minus a first. X is 7 minus 0 by 3 minus 0, it's 7 by 3. And then d minus x by d minus c, which is equal to 9 minus 7 by 9 minus 6 is 2 by 3. Right? Since we are taking minimum of 7 by 3, 1 and 2 by 3, 2 by 3 is a minimum. Right? That is equal to 0.67. Okay? And then we are taking maximum of 0.67 and 0, which is equal to 0.67. Right? Okay, so Yamuna, Abhishek, Abhirami, Suresh, Renu, and Sayan, all of you are absolutely right. Okay, so Anurag had a question from the previous thing, right? Okay, so Anurag, let me just say the question again. So we are having a trapezoidal membership function where a equal to 0 and b has been changed from 2 to 4. Okay, initially it was 2 and then we have changed it to b equal to 4, and then we have c equal to 6 and d equal to 8. And what we are giving, what is given in the options is that for the values x equal to 1 and x equal to 7, the membership function is equal to, membership function value is equal to 0.5. Similarly, for x equal to 2 and x equal to 7, the value is 0.5. For 4 and 7, again the value is 0.5. So which of these statements are true? So what we eventually did is that in this formula, I mean in this membership function, trapezoidal membership function, where we find the minimum and then the maximum from these, we'll finally get one value for a given x value and for the given a, b, c value, a, b, c, d, e, sorry, a, b, c, d values. Okay, so we basically put all these a equal to 0, b equal to 4, c equal to 6, and d equal to 8 into these, and at x we put 1 for the first time, and then you try to get the membership value, and that will turn out to be 0.25. And when you put x is equal to 2, then you get 0.5. And when you put x equal to 4, then you will be getting 1. So I haven't explicitly done everything how to do, because we have already covered this kind of a similar question for triangular membership function as our second or third question. So hence I have directly given it here for others to do. Okay, and I have given you the answers. So now with observation, you can say for x equal to 2 and x equal to 7, you are getting a membership function of 0.5 and 0.5. And hence we are saying option B, which is x equal to 2 and x equal to 7, has a membership function value is equal to 0.5 as the right answer. Okay. Uh, I hope. Okay, cool. Very good. Uh, so any more questions, anybody? So in case if anyone has any questions during the week, you can either post it on the Google groups. In the NPTEL portal, you will find the as ask a question, I guess. You see that Q&A. It's written as Q&A tab in NPTEL portal. So in case if you have a question during the week, you can just go to that Q&A and you can drop your question there. But in case if you want to have a one-on-one discussion, you can always come back here every Friday from 6 to 8 and then drop a message here. Okay. So during the class, I'll be discussing mostly assignments and mostly MATLAB code and all of that. In case if you all need any help with coding and all of that in MATLAB, also I'll be available. Okay, so you can always text me. Sorry, you can always ask me about it, and I'll be sure to answer everybody's thing. Okay, so any other questions from this whole week's part? Okay, and also if you find any uh, mistakes in the assignment, like the in the weekly assignment, uh, immediately send it in the Google group. Okay, so that the course TA will have a discussion with the professor and directly send it to the NPTEL people. Okay. Um, right now it is sufficient because even my system doesn't it does not have the capability to support the MATLAB application. So if I open that, everything else will crash. So right now even I'm using online. So I'll try to make it available for MATLAB as well. Uh, I mean MATLAB online as well. Okay, so whatever I'm trying, but in case if there comes any functions where the whole thing is like the whole application is required, then we definitely have to see. So I have checked that in MATLAB online. So at the top you'll find add-ons. Go to add-ons and directly add the fuzzy logic toolbox. So that is what I did, and it's working absolutely fine for me for now. Okay, so I hope it's fine. Okay, in case for that week you require an application, I'll send a message in the Google groups. Okay, I'll just notify you beforehand. Okay, for at least a day or something, try to get your friend's laptop who has MATLAB installed. Okay, so, but 99% I'll try to keep it for online version as well. Okay, so that you will not have any issues. Is that okay? Cool. Any more questions from anybody? Okay, if you're not having any questions, thank you for joining today. The first class has been amazing. Thanks to all of you who were answering each and every question. You guys are amazing, and thanks a lot for being here. Yes, the recordings will be posted on YouTube, and the YouTube link will be given in the NPTEL portal. Okay, you will be getting the recordings. You will be getting this whole notes. You will also be getting the MATLAB files. Okay, everything will be made available in the NPTEL portal. Most likely by tomorrow afternoon or at max tomorrow evening, I'll upload everything off. Okay. Uh, yeah, it is recommended that you have basic of MATLAB. Yeah, that is required, kind of required, and it is not that hard. It's almost like Python, almost, but not similar. The syntax and all of that changes quite a bit. I have given a little bit of introduction for MATLAB in between, maybe around 6:45 or something. So that is just for how to use the membership function and how to plot. Okay, but if you want to go deep and to know more about MATLAB, in MATLAB online, you have MATLAB on RAM course. So basically, they teach you the basics of MATLAB, and if you are interested in Simulink, you can also take Simulink on RAM. So these are two free courses that are provided by MATLAB itself, and you'll get certificate at the end. So it won't take that long. You will probably finish it off. Okay. So in case you're interested in learning more MATLAB, that is the way to go. So that's how I learned MATLAB long back. Okay, so I'll wait till 8 p.m. In case if anyone else has any questions in between, just do drop messages here. Okay, I'll be waiting here till 8. And if not, thanks a lot for joining. Have a great weekend. Bye bye.